In this video, let's look at some basic ideas dealing with graphing. And so by graphing, I don't mean like a statistical graph. I mean like the sort of graphing you did in algebra on an XY coordinate system. So we're not going to do a whole lot with this, but you do need to have a basic idea of what's going on here. So, you know, a number line here. Ooh, let me get a different pen. A number line has 0, and then it numbers positive numbers off to the right. So like 1, 2, 3, 4, 5. And it just keeps going. And then negative numbers off to the left. And it keeps going to the left. And so with this, you can graph any single number. It would be somewhere along this line. So if you need to graph an ordered pair, what we need is a second line. So by an ordered pair, I mean two numbers, like -5, 3, or 1, -2, or 3, -4, or something like that. These are some examples. So we're going to do a second line, and going up will be positive, and going down will be negative. And this will go up forever and down forever. And so what we can do is we can take any ordered pair, and what we do is we let the first coordinate be the x, and this horizontal axis, that's the x-axis. The second coordinate is the y, and that's going to be this vertical axis. And now to graph an ordered pair like -5, 3, the -5 is the x-coordinate. So we go to -5 along the horizontal axis, and then 3 is the y-coordinate. And so we're going to go up 3. So -5, up 3, and where these two cross, you're going to put an ordered pair. And that'll be the graph of the point -5, 3. So 1, -2, I'm going to go over 1, down 2. So that'll be 1, -2. 3, -4. This will be going over 3 and down -4. So that would be like this. 3, -4. They could both be negative. -2, -5. So this would be -2 on the x-axis, -5 on the y-axis. So that would be -2, 5. Another possibility would be if you had a 0. So if I had 0, 4. This would be 0 on the x-axis, which is right here, and then 4 on the y-axis, which is right here. And so that would actually be an intercept. An intercept is a point that actually lies on the axis. It's when one of these are 0. So another example, if I had 2, 0, this is going to be an x-intercept. Okay, so my x is 2, but my y is 0, so my y doesn't go anywhere. So I'm there on the x-axis, 2, 0. Okay, and so that's the idea of graphing points. I remember, math wasn't my favorite subject in high school, and I remember this idea of graphing points making a lot of sense, and it was fairly easy. It was when you started making graphs of lines and circles and things like that. That's when things got difficult. And we're not going to do a lot of that. You need to be able to graph these points because we're going to make scatter plots. Because when you do a correlation study, which studies the relationship between two variables, the x will stand for one variable, the y will stand for another variable, and you need to be able to plot the points on a graph, and then you can see if those points have a pattern to them, like are they going up together, down together, things like that. So now one thing that I do want you to be at least familiar with, we're not going to be doing a lot of graphing lines or anything, but I want you to understand kind of the slope and the y-intercept of a line. So we're just going to very briefly look at that. And so let me do an XY coordinate system. And so we're going to graph some lines here. Okay? So a line, the lines that you'd graph in algebra are of this form: y equals mx plus b. Okay? And this is where m is equal to the slope of a line, and 0b is the y-intercept. So let me explain what this means. Let me give you an example. Let's say we have y is equal to negative 3 halves x plus 5. Okay, so this is where the slope here is going to be negative 3 halves, and the y-intercept is going to be 0, 5. So the idea here is the number here by itself, in this case the 5, that's where it crosses the y-axis. And so you put the y-intercept on that vertical axis, wherever this number is. So if this was minus 3, I would put it down here. If it was plus 2, I would put it here. In this case it's a plus 5, so I put it there. So this gives you where it starts on the y-axis. So the idea of the slope is it tells you how the line is tilted. Okay? And the way that it does that is that the slope is, we say, the rise over the run. Or sometimes we say it's the change in y over the change in x. So the rise meaning, are you rising up or down, and how much? And the change in x is back and forth. That's the run. So the rise and the run. So this slope here is negative 3 over 2. So what that means is, to get the slope of my line, I'm going to be going down 3 over 2. And that's going to be the next point on my line. And then if I go another space over, I'm going to go down 3, 1, 2, 3 over 2. So now down 3 over 2. This would be the next point on the line. And you can see that these are all going to be on the same line. And what they say is graph at least 3 of these so you know that they line up on a line. Okay? And so then you can draw the line through those points. And this is the graph of that line. Okay? So the y-intercept is 5. The slope is negative 3 over 2. So it means I go down 3 for every 2 I go over, down 3 for every 2 I go over, down 3 for every 2 I go over. And you can see that that's going to give me the slope. Okay, if it were, let's say this were negative 2/3, it would mean I would go down 2 for every 3 I go over, down 2 for every 3 I go over, and then it wouldn't be quite as steep. But 2/3 is smaller than 3 halves, right? So the bigger that is, the more steep it's going to go down. Same with a positive slope, okay? Let me say, and I'm going to do one with a positive slope here in a minute, but let me say one other thing, is that negative 3 over 2 is the same as 3 over negative 2. Okay? So it doesn't matter. You could have the negative in the top or the negative in the bottom. And if I had the negative in the bottom, what this would mean is I would go up 3, and then I would go back 2, but that would just be, so if I went up 3, back 2, up 3, back 2, those would just be more points along the same line. Okay? So you could either go down 3 to the right 2, or up 3 and back 2. Okay. And then let's just do one more. Let's do something like this. Let's do y is equal to 3x minus, we'll say 4, something like that. So let me draw my axis. And if I want to graph this, the y-intercept is -4, so I'm going to put a dot right here for my y-intercept. And then the slope is 3, okay? So the question is, how do I do the rise over run here? Well, I just take the 3 and I put it over 1. So if it's just a whole number, then you put it over 1. And what this means is I'm going to go up 3 for every 1 I go over. So I'm going to go up 3 over 1, and that would be a point, the next point on my line. And then up 3 over 1, that'd give me another point on the line. And then up 3 over 1, that would give me another point. And you can see then that these are all on the same line, and the line would be y equals 3x minus 4. This is y equals -3/2 x plus 5. Okay, so that's graphing lines. And the idea behind this line is all the ordered pairs on the line, if I plugged in the x and the y coordinate in here, then I would get the same thing on both sides. Okay, it would satisfy this equation. Same here, all the points on this line would satisfy that equation. So I do remember doing this in high school, and I remember this being okay too. This idea of plotting the y-intercept and getting the other points on the line by using the slope, the rise over run, and then you get several points, and then you can draw the line through those points. And besides this, this is probably all the graphing that you'll need for this course. And where we'll really use this is when we analyze a correlation study where we make scatter plots, and then we try to find the line of best fit. It's going to be a line that fits the data the best, and the line of best fit basically amounts to, we're going to be given some formulas to figure out what the slope and the y-intercept is going to be for the line that fits a scatter plot the best, the data that you get from your correlation study. So besides that, though, we're not going to do anything else with graphing.